be simplifying, okay, where we have to factor some parts. Now you have a complex fraction. Okay, that means you're going to have a fraction and another fraction. Okay, I'm going to explain it, and then it will make a little bit more sense. So, a complex fraction is a rational expression with a numerator and or a denominator. That is also a rational expression. Okay, so the following, quiet please. The following expressions are complex fractions. So if I have c over 6 over 5d, okay, there's a fraction in your numerator, and then there's a second denominator there. This one, again, we have a fraction in that numerator, and then an expression in the denominator. This one, you have a fraction over another fraction.
Seriously, I would have thought.
Now, this fraction bar here, okay, that always means divided by. Okay? Shh. That fraction bar means divided by. Okay, in all of these cases. You could also have one like this, where you have a fraction plus a whole number, or plus a variable over another fraction, and then add or subtract a variable or a whole number. Okay, so to simplify a complex fraction, you want to rewrite it as a division expression first. Okay, so that's why I pointed out that this fraction bar means divided by. So in our first example here, I have x minus 2 squared over 2 times the quantity x squared minus 5x plus 4. That fraction there is divided by x squared minus 4 over 4x minus 10. So I'm going to take that numerator fraction, so this part right here, and I'm just going to rewrite it off to the side.
Yeah.
Okay, so that was the numerator.
Now flip it.
You will flip the other one. But this fraction bar here means divided by, so I'm going to rewrite it as a divided by expression. Okay, then I can write this denominator out. So I have x squared minus 4 over 4x minus 10. Now, last week, we turned that division expression into multiplication. Now, when we did that, you have to flip your numerator and denominator. Okay, so here again I have x minus 2 squared over 2 times x squared minus 5x plus 4. And I'm going to change this to multiplication. And when I do that, I need to flip the numerator and denominator. So I have 4x minus 10 over x squared minus 4. Now from this point, it's just the same thing that we were doing last week. So you want to factor each of these if they're able to factor. So instead of writing x minus 2 squared, I'm actually going to write out x minus 2 times x minus 2, because I know there's 2 of those. Now, your numerators are multiplied together, so I'm just going to combine those right away. Now I can factor something out of this one, right?
The 4.
Not the 4. 2. I can factor out a 2. Is it okay if I write that out front? Are you good with that? Or can I do that? Should I write it over here? Okay, so this I'm factoring to 2 times 2x minus 5. I did grade your test.
Is that just x minus 5?
2x minus 5. Okay, that's over. In the denominator, I have this 2. So I'm going to rewrite that 2. Next, I need to factor this. Okay? this trinomial. So if you need to, again, off to the side, we can do that x method. So what multiplies to get positive 4 and adds to get negative 5?
4 and 1.
Yes. Okay, so instead of rewriting this now, I can write it as x minus 4 times x minus 1. Now what about this one? I have x squared minus 4. Do you remember? If both of those terms are perfect squares, which they are, right? And there's subtraction between,
And multiply it.
I can factor it into a plus and minus of those squares. Okay, so I have x plus 2 and x minus 2. Okay, so you take those square root of both of those and you have a plus and minus between them. From this point I can start to cancel things out. Okay, I have a 2 in the numerator and the denominator. I also have an x minus 2 and an x minus 2. Alright, I don't have anything else in common. So rewriting this out, I have x minus 2 times 2x minus 5 over x minus 4 times x minus 1 times x plus 2. And that would be your simplified answer. Hey, pay attention. Questions on the first example? Okay, so again, your first step, pay attention please. Your first step is to change that fraction bar into the division symbol. Okay, once you do that, you can change that to multiplication of the reciprocal. Then you can start to factor each thing out and then cancel out common terms to get your simplified answer. Okay, looking at the next one. Okay, we have x squared minus y squared over y squared minus 49. That is, again, over. So using that larger fraction bar there. Again, that's still divided by. Then we have y minus x over y plus 7. Okay, so again, first step is to change this into a division expression. So we still have that first fraction in that numerator there. So we have x squared minus y squared over y squared minus 49. That is divided by that denominator of y minus x over y plus 7. Okay, now once we have it as that division expression, I can change it into multiplication. So we have x squared minus y squared over y squared minus 49. And we want to multiply by that reciprocal. So y plus 7 over y minus x. Okay, from here I want to start factoring. Okay, this first one, I have an x squared and a y squared. I can take the square root of both of those, right? There's a subtraction between. So again, we can split this into a plus and minus. So I have x plus y times x minus y. Okay, then I still have this multiplication. My other numerator is y plus 7, so I'm just going to write that out right away. Because I can multiply straight across. That is over. Again, here I have a square and a perfect square. So we can make this y plus 7 times y minus 7. And right here, again, I still have this y minus x. And I can start canceling. Okay, so right here, I have a y plus 7 and a y plus 7. Now what I want you to notice is that these two are kind of similar, right? This x minus y and y minus x.
Yeah.
Yeah. So I'm going to write this out again after I canceled. So this one right here, do you remember what I can do to make it look like that denominator?
You multiply it by -1.
Not multiply, we're going to factor out.
Sorry.
But yes, right thought.
Wait, you still multiply it by -1?
Yes. Yes.
Okay, so you factor it out.
Yes, it's the same thing. Okay, so we want to factor out a -1 there. Okay, so I'll have -1. This x plus y stays the same. That's not the one I'm factoring it out from. Hey, shh. You're factoring out the -1 from this one right here. That means your signs change inside those parentheses. So this is -x and plus y. Okay, that's over y minus 7 times y minus x. Now those two are the same. Okay, both have a -x and a positive y. Okay, so we can cancel those out now. Okay, then just rewriting, we have -1 times x plus y over y minus 7, and you can keep it like that. You don't need the 1 there. If you just write negative, that's fine. Questions on this second one here? Okay, so again, change it into a division expression first. Then you want to change that to multiplication of the reciprocal. Then you want to factor just like we were last week. All right, one more example on the back. So again, you have that middle fraction bar, that's your divided by. So I'm going to rewrite that numerator. So we have x squared over 9x squared minus 4y squared. Okay, so again, rewriting the numerator. We're dividing that by that denominator of x cubed over 2y minus 3x. From here, we want to change that to multiplication. Okay, so we'll have x squared over 9x squared minus 4y squared. To change it to multiplication, I need to multiply by the reciprocal, that second term. So we have 2y minus 3x over x cubed. Okay, at this point I can start factoring. So in that numerator, I can't factor anything out of that numerator. I can just multiply those. So I have x squared times this quantity here. So 2y minus 3x. Okay, that's your numerators multiplied together. Now in your denominator, this 9x squared and this 4y squared. If I took the square root of this whole term, what would I end up with? 3x. I'd end up with 3x. Take the square root. Okay? If I took the square root of 4y squared, 2y. And I have subtraction between, so I can split this into 3x plus 2y times 3x minus 2y. Okay, that's that plus and minus thing. And then I still have this x cubed. Should I write it back here or do you want it up here? Doesn't matter.
Don't care.
Front.
Okay. Alright, so I can start canceling some stuff here. I have an x squared on top and an x cubed on the bottom. Okay, so the one on the top will cancel, but you still have one left in that denominator, right? So I still have an x. Now, again, just like the last problem, these two look similar, but you can't cancel them out yet. Okay, so in that numerator there, we want to factor out -1. Okay, you can't just cancel it out, you got to factor out -1 first. So we'll have -1. That changes the sign of both of those terms. So now I'll have -2y plus 3x. That's over. I still have that x left. And we have 3x plus 2y and 3x minus 2y. Now those two are the same. You have a -2y, a -2y, positive 3x, positive 3x. So now I can cancel those out. Okay, and then I'm left with -1 over x times 3x plus 2y. And that would be your simplified answer. And yes, you need the 1 for that one. Still has to be a fraction. Any questions? It's really similar to what we've been doing. You just need to do an extra step. Okay? If you think you can do more than one thing at a time, so if you want to skip this step and you know you just need to multiply by the reciprocal right away, then do that. If you don't think you can skip this step, then write it out. Okay? Are you good? Any questions?